Okay, so in the last lesson I explained to you how a simple conditional flow statement, in this case an if statement, works at the machine code level. It basically takes two machine code instructions. Now I'm going to show you how to create a simple if statement in C. So as you see, I have the structure of a basic program here. Let's go ahead and create a variable. And we're going to write an if statement that will test if height is equal to 5. And then we're going to display some text if it is equal to 5. So how do we do that? So first of all, we write the word if, and then we put the condition that we're testing for within parentheses, like this. And now, if you remember from the previous lessons, you basically have to define a block of code, which are the statements that you want to have execute only if the condition evaluates to true. In C, the way that you define any block of code is with braces. You put an opening brace at the start of the block of code, and you put a closing brace at the end of the block of code, just like this. This is entirely valid. Of course, these need to be valid C statements, but this is how you do it. Now, there are two ways that you can format the code. You can either have the brace directly under the if statement, like I just did, or you can put it on the same line as the if statement, like this. Either way is perfectly fine. It's just a matter of preference. Notice up here, it's the same concept as how we created the main function. So the next thing is, how do we specify the condition being tested? How do we write if height is equal to 5? The answer is like this. We write if height is equal to 5. You need two equal signs when you're doing a test. One equal sign does not mean is equal to. One equal sign means assign the value. So over here where we have one equal sign, what we're saying is assign height the value of 5. Two equal signs means is equal to. So always remember that. One equal sign, you're assigning a value. Two equal signs, you're testing if it is equal. And it's important that you not get that confused. If we were to write this, what we're basically doing is we're assigning height the value of 5. We're not testing anything. And we'll get into exactly what happens with this later. But for right now, I just want you to remember that whenever you want to do a test, you must use two equal signs inside of the parentheses of an if statement. So let's go ahead and create a valid statement here. Let's do a printf function. The value is 5. Now if we run our code, and there you go, the value is 5. Okay, so what if you have a situation where you want to test more than one thing? So here we're only testing if height is equal to 5. Let's create another variable. And let's suppose that we want to test if height is equal to 5 and if width is equal to 10. Well, one thing that you need to understand is that at the machine code level, and every program you write will get translated to machine code in the end. At the machine code level, it is impossible to test two things simultaneously. You have to choose which condition you're going to test first. So if we want to test both if height is equal to 5 and if width is equal to 10, we have to choose one to test before the other. So let's go ahead and do this. We're going to say if height is equal to 5, and then inside of that we're going to put another if statement, if width is equal to 10, and we can do that. Now the way you would read this code is like this. You would say if height is equal to 5, then do this. And then you would say if width is equal to 10, then do this. Now let's go ahead and create another variable. We'll call it length. We'll set it a value of 20. So here we can choose where we want length to be in this series of if statements. Let's put it here. And we can say if length is equal to 20, and we'll just change this printf statement to something else. So this is one way that you can write 3 different if statements in C. There is, however, another way that you can do this, which is something that is a little easier to read and maintain, and that is you can place more than one condition into a single if statement. So I'm going to show you how to write this code with a single if statement. So here's how you do that. You write if, and then you put the first condition, if height is equal to 5, and now you put 2 ampersands. This just simply means that there's going to be another condition evaluated, but only if this evaluation is true. So if this evaluation fails, if height is not equal to 5, then it's not even going to look at whatever is beyond this point. It's just going to immediately consider that the if statement failed. So you can think of these 2 ampersands, pronounce them just simply and. So we can say here, if height is equal to 5 and, let's say width is equal to 10 and length is equal to 20, and then we can go ahead and place our printf statement right in here. Printf, we tested the values. Same thing. So this code and this code are functionally equivalent. Now here are a few points that I want you to remember. One is that whenever you have a series of if statements, you're always going to evaluate them in a specific order. And you are only going to evaluate the next expression if all of the previous expressions have already evaluated to true. So for example, if we say if width is equal to 3, which it is not, width is 10, so this is going to fail, then what's going to happen is when this executes, first this will be evaluated. Height will be compared to 5. If it's true, it's going to proceed. Now width is going to be evaluated to see if it's equal to 3. If true, then it's going to proceed. But since it's false, it's not even going to look beyond this point. It's going to immediately just jump here. So it's going to skip over this printf statement using the machine code instructions that I showed you earlier, where it's going to jump if not equal, and it's just going to jump down here. So remember, every expression in an if statement is evaluated based on the previous expression. So the only way that this last expression is going to be evaluated is if all of the previous expressions are true. Now this is important for a number of reasons. One is that sometimes when you're writing a program you need to test more than one thing, and each test can be more complex than the other. So for example, you might need to test something that's very simple and something that's very complex that requires more CPU resources. In those situations, you should always test the least complex condition first. That way, if it fails, you don't have to expend the additional CPU resources to test the more advanced condition. Let me show you an example of that. So let's go ahead and delete this code for right now. And we're going to take out the length. And let's put a new condition here. We're going to put a printf statement. Now remember, printf has a return value that is equal to the number of characters printed. So in this case, 4 characters are going to be printed. So we'll say like this. We'll say that if the printf statement returns 4, then that's the final evaluation. Let's go ahead and set this to true. So we're going to set this entire if statement to something that's going to evaluate as true. Height is equal to 5, width is equal to 10, and this printf statement is going to return 4. Now if we run this program, notice 2 things. First of all, notice that the printf statement did execute. You see that 1, 2, 3, 4 right here. And you see that this printf statement also executed because in fact all 3 conditions were true. Now it should be apparent to you that this test is substantially more complex than the tests that came before it, because this requires that we have to actually execute the printf function. If we were to set either of these to false, let's say if width is equal to 3, which it is not, then notice that this test will not even happen. Look what happens when I run this code. Notice that neither printf statement executed because as soon as it is seen that width is not equal to 3, there's no need to test further. It's just going to skip over and jump right here in the program. So keep in mind that every extra expression in a conditional statement takes some amount of computing resources. And something like this, where it's involving actually calling a function, it makes sense to put the more complex test after the least complex test, because that way if this fails, then there's no reason to spend more CPU resources, let's say, calling a function when you don't need to. Now, before we end this lesson, there's one more thing I want to show you about if statements. So let's suppose that we write out this code. If height is equal to 5 and width is equal to 10. And we'll have, let's say, some printf statement. So what you need to understand here is that each condition is being evaluated to either true or false. Think of true and false as 1 for true and 0 for false. So when we have this condition of height is equal to 5, it's either going to evaluate to true or false. So we can look at this and we can say, yes, height is equal to 5, so we can think of that as just simply being true, or 1. And then we have this expression being evaluated, which is width equal to 10. So again, we look at that, we can say width is equal to 10, so this again is going to evaluate to true. And now we can see that both of these being true itself evaluates to true, and what we're left with is basically this. Now on the other hand, let's go ahead and rewrite this condition in a way that it's false. If we say if height is equal to 5 and width is equal to 3, well then what happens? We're going to look at the first condition being tested. If height is equal to 5, that's true. And now we're going to proceed to the next expression. That's false. And now we can see that true and false basically means false, because they both have to be true. All expressions have to be true for the if statement to be evaluated to true. So then we're basically left with this, which means that we're not going to execute what's inside of that code. Now notice this is entirely valid C code. You can do this. See, if I run this, notice that it doesn't run, because the 0 basically means false. Now if I replace this with a 1 and I try to run it, then you'll see that it works, and it will evaluate as true. The reason that I'm showing you that is I want you to have an idea of how, as a programmer, you look at this code and evaluate it inside of your own mind, one expression at a time. So if you're going through this code and you're trying to figure out what's happening, you might say, okay, if height is equal to 5, okay, that's true. If width is equal to 10, okay, that's true. Now both of these are true. And then length is equal to 20, that's true. Okay, so this whole if statement is going to be true. And that's just simply a way that you can understand this when you're reading the code. So remember that the entire if statement will only evaluate to true if every single condition being tested evaluates to true. If any condition fails, then two things happen. First of all, the if statement itself fails, and you're not going to execute what is inside this block of code. And second of all, whatever expressions occur later than what failed will not happen. So for example, if we're testing if width is equal to 3 and it's not, then this will not even be looked at. Now, I highly encourage you to experiment with the code you've seen in this lesson and practice writing your own if statements to make sure that you understand these concepts. All right, that concludes this lesson.